Welcome. This video is going to take a closer look at forming ionic bonds. Now that we know how positive ions tend to form and negative ions tend to form, we're going to look at how does the actual bond form and how do you know if the formula is NaCl or MgCl2. So electron transfer is defined as when one atom loses electrons and another atom gains those electrons. So that means both a positive ion and a negative ion will form, and the positive and negative ions will attract each other, which is then what we call the ionic bond. The compound that forms when positive and negative ions attract each other is an ionic compound. It almost always involves a metal with a nonmetal. So the metal's losing, the nonmetal's gaining. And when a metal combines with oxygen, or what you maybe have heard of is called oxidation, we call the product an oxide. Otherwise, any combination of metals and nonmetals is also called salts. So that's just kind of the layman's or day-to-day term for ionic compounds is what you've known as salts. Ionic bonds are also often binary, which means there's only two elements being combined, one metal with one nonmetal. But the bond won't form unless the number of electrons being lost is equal to the number of electrons being gained. So binary means only two kinds of elements being combined, but it doesn't mean there's just one of each kind of atom. It's not always just NaCl. It can be MgCl2 or AlCl3. So the question is, so if we look at some examples here, it says, in what ratio will sodium and chlorine combine? Well, the first big question is to find out what family each of these are in. And sodium is in family 1A, and chlorine is family 7A or 17, whichever you prefer. So that tells me that sodium is likely to pick up a +1 charge. It's going to lose that one electron. Whereas chlorine is likely to gain one electron, because 8 minus 7 lets me know it's likely to gain 1 to get to 8. And so it's likely to pick up a -1 charge. And the idea of coming up with the charge that an atom will likely pick up to form an ion, that's referred to as the oxidation number. And it's really an important way to be able to figure out what the ratios are. So this one's pretty easy. I can see that sodium loses 1, chlorine gains 1, so one of each would be just perfect. I'm losing and gaining an equal number. Both atoms are getting to what they need to be. Let me show you a couple other ways to think about this before we go on to 2 and 3. I like to either draw a box and show how many electrons sodium is going to lose. So I draw the electron as a plus sign. And I draw my nonmetal and show how many electrons it's likely to gain. And that's also 1. And then I look and see, do those two numbers match up? Do the number of electrons work? The number lost equals the number gained. It does. So this ratio would be 1 to 1, or the formula would just be NaCl. Another way I can think about it is more of a mathematical relationship. I can think about, so I would think about what my two elements are combining. And I would want to know the charge each one is likely to pick up. And then I need to know my least common multiple. And from that, I need to determine the number of each needed. So my sodium, like we said, is likely to pick up a +1, chlorine a -1. The least common multiple of 1 and 1 is just 1. So +1 and -1 will give me a charge of 0 overall. And so how many of each do I need? Just one of each. Because then my total charge is +1 for the sodium, -1 for the chlorine, and when I add those two charges together, I get an overall charge of 0 on the ionic compound. So let's look at a slightly more complicated example. What would be the chemical formula from an ionic compound formed from calcium? If you look and see, calcium is in family 2A, and it's going to lose those two. Sulfur's in 6A, so 8 minus 6 means it's going to gain 2. And if I draw my picture again, I see calcium has 2, sulfur will gain 2. Again, For each electron lost, somebody's ready to gain it. So this is just going to be a 1-to-1 ratio, or CAS. Otherwise, if I use my other method of calcium and sulfur, the charge for each one is +2 and -2. The least common multiple will be 2, because 2 plus -2 will give me 0. So that lets me know I only need one of each for them to balance out. The third one, how about iron with a 3? And I deliberately put this one because this is letting us know iron's a transition metal, so it has 2 valence electrons, but because it's a transition metal, it's moving another electron out there, and it's going to pick up a +3 charge. That's what this is telling me. It's telling me the charge iron's going to pick up. Oxygen over in family 6A is going to pick up a -2 charge. And now this one gets a bit messier, so I'm going to scroll this up a little bit so I have room to show you. So I have Fe giving off 3 electrons, and I have oxygen only able to take 2 of these electrons. So now one of each is not going to work. And so right now I'm losing more electrons than oxygen is gaining, so I need to bring in another oxygen. And when I do that, now I have, if I look, I've got 3 of them taken care of, but I've got an extra electron needed by oxygen. And remember, this bond isn't going to form if both elements aren't completely satisfied. So I bring in another iron, which seems to mess it up even more. But I get that oxygen satisfied, so now I bring in one more oxygen. And finally, I have reached my ratio of 2-to-3, or Fe2O3. And if I do this using my other method, I would Fe and O. I know this is +3. I know this is going to pick up a -2. Now my least common multiple is 6. So I need to lose 6 electrons so oxygen can gain 6 electrons. And overall, I have a charge of 0. So that would tell me I need 2 iron and 3 oxygen. And either of these methods will work well for you as you're getting used to the idea of figuring out ratios or ionic bonds. So here's a try it for you. I would suggest that you pause this and see if you can do any or all of these on your own. Periodic table will definitely be helpful. And then I'm going to go ahead and proceed with my solutions, and hopefully you've come up with the same ones. So question number 1, in what ratio will lithium and phosphorus combine? I see lithium in family 1A, so that means it's going to lose that 1 electron. Phosphorus is in family 5A, so 8 minus 5, it's going to gain 3. So now, when I draw them, lithium only has 1 to lose. Phosphorus is looking to gain 3. So 1-to-1 is not going to work. The lithium will be okay, but the phosphorus has not become more stable. So I'm going to have to bring in a second and a third lithium in order to get all 3 electrons that phosphorus needs. So that tells me that I have a 3-to-1 ratio, or the formula would be Li3P. What would be the chemical formula for copper 2 and sulfur? Remember, copper 2 is telling me that this picks up a +2, sulfur a -2. So this one, copper has 2 electrons to lose. Sulfur has 2 electrons to gain. In this case, a 1-to-1 ratio is just perfect, and this is CuS. And then my third question on the try it, why can't sulfur and oxygen form an ionic bond? Well, if you look, you see sulfur is a nonmetal that needs to gain 2 electrons, and oxygen's also a nonmetal needing to gain 2. And so they're not going to form an ionic bond since both need to gain. The only way an ionic bond forms is when you have one metal that is more likely to lose, bonding with a second element that's more likely to gain.